going to look at how you know how to round off your answers or where to round off your answers. And there are two main rules, and they're different for whether you're adding or subtracting. There's one rule, or if you're multiplying or dividing, you have a different rule. So if you're adding and subtracting, the easy way to say that is line them up and cut them off. And what I'm talking about is lining up the decimals and then when you cut them off, you're going to cut off your answer by the number that extends least far to the right. So that's I'll show you how that works out. Let's look at a couple of examples. It's a little easier to see it. So line them up, line up your decimals, and then look at how far they extend to the right. And both of these numbers extend one past the decimal, so there's nothing to cut off, but that tells me that my answer is going to have all of those digits because they both went to the, I wasn't limited by either one. Now note, I gained sig figs here because this top number has 2, the bottom number has 2 sig figs, but my answer has 3. Okay, so that can happen, and that's an important thing to note. When you add and subtract, the number of sig figs can really increase or decrease. It can really change. So sometimes you gain sig figs, sometimes you'll lose a lot of sig figs. In other words, in this case, this top number has 2 and the bottom number has 3. So, but we're going to see it's going to be totally something different with our answer. Let's look at our answer. So the top number, this 0 is significant because the dot is shown, but it doesn't have any digits past the decimal. So that tells me I need to cut off my answer there, which means I'm only going to have 1 sig fig in my answer. For this answer, I'm going to have the ones place here, but I need to look 1 to the right, and that is a 5, so this will round up. So my answer here is just 9. So this is a case where I really lost sig figs. I had 2 and then 3, and then this answer had 1. So adding and subtracting, line them up, cut them off. Multiplying and dividing, what you do is you look at all the numbers that go into the calculation and you see how many sig figs they have, and then you round according to the one with the least number of sig figs. So in other words, this top number has 3 sig figs, bottom number has 4 sig figs, and so I need to, this is what my calculator said, but I need to round it to 3 because that's the least. So I'm going to say 12 point, and then again, I'm rounding this when I look, this is a 5, so that does round up. Let's look at another one. This one only has 1 sig fig. This is a leading 0, it doesn't count. This one has 5 sig figs. So I need to round this to 1 sig fig, and that's kind of tricky looking. Let's think about how to do that. So I'm going to round it to this place. So I can't just say like 11. I need to show, and basically rounding it to 10. But anyway, so if I did like that and tried to show that one not significant, that actually works right there because that has 1 sig fig, which is what I wanted. I can't put the dot though. If I did this, that would have 2 sig figs, and that's not correct. Oh, yeah. Does this round up? No, it doesn't round up. This digit would round up, but that one doesn't. So anyway, that is the correct. I could also, though, if I wanted to write this in scientific notation just as an option to show that it has just one sig fig. Okay, another thing that comes up are exact numbers, because sometimes you're doing calculations and there are exact numbers that you ignore when it comes to sig figs. And so before doing an example, let's define how do you get an exact number. This is a number that is perfect with no error. There are two main ways. Numbers that are exact by definition. An example of that is that there are 60 seconds in 1 minute. And that is exact by definition because we defined it that way. It's exactly 60 seconds in 1 minute. So if I'm doing a calculation with this 60 or that 1, I'm not going to worry about how many sig figs they have because they're perfect numbers. Remember, sig figs are for numbers that have error in them or are estimated. The other way I can get something that's an exact number is if something can be counted. In other words, like if I'm counting eggs or people or pennies or something like that, the number of people in the classroom is 24. That is an exact number. Let's look at an example using an exact number. So say I have 24 students. This is an exact number. And they're using some solution and I want to see how much total they're using. So I multiply this out, and when I'm assessing how to round this off, I'm going to ignore this for sig figs. I'm going to go by this one. This one has 3 sig figs, so my answer here should have 3 sig figs. This is just what the calculator said.